Hi everyone, welcome to this P.Eng's technical exam preparation series for elementary structural analysis. In this video, we'll look at question number 1, which asks whether a structure is stable or unstable, statically determinate or indeterminate, and if indeterminate, we need to calculate the degree of the indeterminacy. Let's first start with the theory before jumping into solving the actual problem. Please feel free to pause and rewind the video anytime to better understand the content. So let's get it started with the definition of equilibrium of a structure. Let us consider a plane body in xy plane is at rest condition, and then it is acted upon by some external forces. So if the body continues to be on the state of the rest even after the application of the force, then the body is said to be in equilibrium condition. And from the principle of the statics, the necessary and sufficient condition of the equilibrium can be expressed as summation of force in x direction is equal to 0, summation of force in y direction must be equal to 0, and summation of moment about z-axis must be equal to 0. So these three equations are the necessary and sufficient condition of equilibrium for a structure in xy plane. The next topic that I would like to discuss is concurrent force system. The concept is important for determining the determinacy or indeterminacy of truss structure. So concurrent force are the force which act along a single point. So for example, if this is our structure and it is subjected to different forces, for example, one in inclined direction, one in vertical direction, and one in horizontal direction, which all meet at point A, then in such case, summation of moment about point A should be automatically equal to 0. Thus, in such case, the equation of the equilibrium are limited to just summation of force in x is equal to 0, summation of force in y is equal to 0. Now let's talk about external and internal forces. As the name suggests, external forces are action of other bodies on the structure under consideration, and they can be further classified into two types. One is applied force and another one is reaction forces. Typically, applied forces are the loads that are being applied to the structure under consideration, and they are usually known. And reaction forces are the forces exerted by the support on the structure and have a tendency to prevent its motion and keep it in equilibrium. So for example, this is our beam and it is subjected to loading of 200 kilonewton. Then the 200 kilonewton force is the applied load, and due to this force some reaction is developed at the supports, and the reaction developed at the supports is called reaction forces, and these forces are crucial for the equilibrium of the structure. And talking about the internal forces, as the name suggests, they are the forces or couples that are exerted on a member or a portion of the structure by rest of the structure. For example, if we consider a frame structure which is subjected to external loading of 200 kilonewton in the vertical direction and 100 kilonewton in the horizontal direction. Let the name of the joint be A, B, C, and D. Then the member AB will be exerting certain force on the member BC, and according to Newton's third law of the motion, member BC will be exerting equal and opposite force on the member AB. So These are the forces which hold the various portions of the structure together, and they are also unknown and they needs to be determined using the equation of the equilibrium, namely the three internal forces are bending moment, axial forces and shear forces. Now let's talk about the supports and their types for plane structure. So supports are used to attach the structures to the ground or other bodies, thereby restricting their movement under the action of applied loads. The load tend to move the structure, but the support prevent the movement by exerting opposite forces or reaction to neutralize the effect of the load, thereby keeping the structures in equilibrium. For example, in this figure, I am sure that this force is trying to push the structure downward. So to resist that, the support will exert force in the opposite direction, which means they try to restrict the movements. Similarly, the force 100 kilonewton is trying to move the structure towards right of the screen, but the reaction at A will try to prevent that movement. Therefore, the supports they try to maintain the structure in equilibrium. Now let's move into types of the support. I'll quickly create a table for explaining the types of the support. So the first type of the support is roller, and it is represented by a circle on the top of a surface, and sometimes it is represented by a triangle with two circles at its base. The structures it will be placed on the top of the supports, and seeing the symbols we can easily identify that it allows the movement in the horizontal direction and it also allows the rotation, but it won't allow movement in the vertical direction. Therefore, we will get only one reaction for roller support, which is in the vertical direction or perpendicular to the surface. One reaction. The next type of the support is hinge. It is just represented by a triangle on top of a surface. And our structures, it will be drawn on the top of the support. So again, seeing the symbol, we can identify that it allows only rotational movement and it does not allow horizontal and vertical movement. Therefore, for a hinge support, we will have two reactions, one on horizontal direction and one on vertical direction. So we will have two reactions for hinge support. And the next support is fixed. It is just represented by a surface and our structure it will be drawn on the top of the surface. It might be drawn in the vertical direction or it might be drawn in the horizontal direction also. So seeing the symbol we can identify that it does not allow movement in any of the above mentioned direction. That is, it won't allow movement in horizontal or vertical direction, and neither it will allow the movement for the rotation also. So we have 0 degree of freedom for fixed support, and we will have three reactions, namely vertical reaction, horizontal reaction, and a moment. So we will have three reactions for fixed support. I would like to discuss about two more supports. One is rocker and another one is link. So for rocker support, it is represented by a triangle with a curved base on top of a horizontal surface. So seeing the symbol, we can again identify that it allows the horizontal movement and it allows the rotation. So it has 2 degree of freedom. So it allows the horizontal movement, it allows the rotation, but it does not allow the vertical movement. Therefore, we will have only one reaction for the rocker. And similarly for link, it is represented by a straight line. The line connects our structural members to a point. For example, this is the surface of a wall. So the links, they are designed to transfer only axial force, and we will have a reaction in the direction of the links. For this case, we might have a reaction on this direction, or it may be on this direction. So we will have only one reaction for link also. So that's all for today. We have gone through different type of the support and understand why each one has a certain number of unknown reaction. It is a very important foundation because it directly affects whether a structure is stable or unstable, determinate or indeterminate, and helps in calculating the degree of the indeterminacy. In the next video, we'll use this knowledge to go through the equilibrium equations and stability conditions, and then we'll start solving question number one step by step. If you find this video helpful, please like and subscribe so that you don't miss the upcoming lessons. Thanks for watching and see you in next tutorial.